Hey folks, time for a new episode of Think Design Work Smart, and what I thought about today is to read through an article from InfoQ. It's a report from April 2021 about software architecture and design trends. And I find this interesting. I just took a brief look on it. Let me show you. Now, it may sound a bit old. April 2021 has been a few months ago, but actually things don't change that much in software architecture, so I shouldn't be too worried that these things are not are not current. First of all, these are written by two very obviously professional people, Senior Principal Software Architect at Blackbaud, Thomas Batts, and Holly Cummins, Innovation Leader at IBM. I'm sure and they know what they are talking about, and it's obvious from the article that this information is very, very interesting and very current. So first of all, as you may know, things for architects, one of the most important parts is to prioritize what it is, what cross-functional requirements or non-functional requirements you must focus on for your specific product. And this is one of the most important parts of architecture, figuring out, because these things often come in clash to each other. They come in conflict, and so you need to pick, for example, how much performance versus how much security or things like that. And the trends have been switching a bit because of the cloud and because we have bigger and bigger applications. And so what's happening is that we definitely need resilience. This is particularly important for large distributed systems like we have today. But what I find interesting is that because we have these kinds of distributed systems, we now have another challenge, which is, okay, so we can have resilience built into our distributed architectures, but when something goes wrong, how do we know where to look? Since highly distributed architectures tend to be harder to diagnose, harder to figure out when something went wrong, and so observability starts to become important. Portability and sustainability, these are other new trends that we'll be looking at. I think these are interesting. Now, another thing that I found interesting in this key takeaway section is we did swing from monoliths and microservices, which are kind of the extremes of a range of options for architecture. So what happened is that we had for a long time monoliths, and then we got into cloud and infrastructure automation and containers, and now we have switched all the way to the other side, which is let's build everything in very small services that communicate through each other, ideally through events, so very decoupled, and that you can deploy separately. And this has been like this for a while because many people have built microservices in a very bad manner, and actually ended up having a lot of problem due to the nature of distributed systems, due to the cap theorem and other things that that happen, like things like observability, right? If something goes wrong with a microservice application, you have 300 services in production, how do we know which one was the one that caused the issue? Or if the issue is distributed between multiple services, how do we found it? And so people have then argued, okay, we don't need microservices, let's go back to modular monoliths. Simon Brown has been one of the proponents of this, and I'm really in favor of doing that. But I also acknowledge that sometimes you need microservices because they allow you to start and to develop much faster. You can parallelize these microservices for development, and then you can actually develop much faster. And when time is of the essence for very large applications, it makes sense to go with microservices, but you need to prepare very well before you do that. And so what we need to do is, guess what? High cohesion and low coupling, regardless of the underlying technology, regardless of these extremes. In the end, this is all we have, really. High cohesion and low coupling, or the extension of low coupling, which is connaissance. So it's very useful to look at these patterns and actually build your products, architect them in a modular way, in modules that are highly cohesive, that have low coupling between them. And if you do it like this, then of course it matters how they are deployed, but it matters less if they are deployed as a module inside of a monolith, as a library, as a service, or something else, right? As a batch job, or So these become very important. We need to refocus on the key characteristics of architecture. Okay, one thing that I know less about and I will be interested in finding out is what happened with GraphQL. GraphQL is an interesting technology, but you can abuse it in the sense that you can very easily write APIs that just expose your database. And I'm not very favorable to such things, because it fundamentally means that what you are doing is you are coupling, you have high coupling between your API and your database structure. And I'm certain that that's not the only way to use GraphQL. This is only the most naive way of using GraphQL. And I understand in certain situations it makes sense, okay? Not everything needs to be complicated. Certain contexts are easier. But you need to pay attention to having low coupling between your API interface and the structure of your database. Because if you change your API interface very often, every time you need to change something in your database, even something internal, like switching from one table to two tables for an entity or something like that, then you might be in a bit of a trouble. Now, of course, there's once again only the most naive way of using GraphQL, and I hope not many people are using it like this, or if they are, they understand that it needs to have low coupling with the API interface. And apparently there are some new things in GraphQL, GraphQL Federation and GraphQL microservices, which would be interesting to look at. Okay, so let's look a bit into this. There's also a graph here. There are some innovators. HTTP3, blockchain, policy as code, WebAssembly, next-gen GraphQL, and these things. So these seem to be coming. Early adopters already, designed for resilience, for observability, micro frontends, low code, no code. Okay. Early majority, we have modular monolith, correctly built distributed systems, actor model, GraphQL, serverless, service mesh, and functional programming. Yeah, functional programming has been gaining a lot of traction nowadays. And apparently in the lane majority area of adoption, we have reactive programming, event-driven architecture. These are pretty common now. CQRS, event sourcing. Oh, interesting. I didn't know these are so common. Eventual consistency. Yeah, if whenever you have a distributed system, you probably choose to have eventual consistency or distributed transactions. Microservices and domain-driven design. So apparently domain-driven design is actually lane majority. That's interesting. All right. So what is interesting here? They refer to the book Release It. I've read this book a long time ago. I remember it was really good, but I actually don't remember much about the book itself. And I had no idea. I didn't remember that they were talking about circuit breakers, timeout retries, and other fundamental requirements for a resilient system. I knew about these things, but I didn't remember where they come from. Anyway, this is interesting for resilience. We need resilience now in our systems because many things can go wrong, and because of that, what we need to do is to take care of these things. So these are a few techniques: circuit breakers, timeouts, retries. They become quite fundamental. Now, interesting, they are also talking about something called Dapper. I think it's Dapper or Dapper, DAPR, which is a framework for building connected distributed applications. I haven't tried this one. It looks interesting because it has some patterns for communication inside between various services, and so it looks interesting, right? So it has things like service invocation, publish, subscribe, secret management, input-output bindings, state management, and virtual actors. All right, so this looks interesting. Might be interesting to try it. Okay, I will take it into account. It sounds quite interesting. Right, they mentioned the Release It. Design and deploy production-ready software. This is a book by Michael Nygaard, and yeah, highly recommend it. Read it. I remember reading it a long time ago, but I actually, as I said, I don't remember the content very well. Okay, so where were we? I think I need to go back here. Okay, we are seeing a higher adoption of asynchronous programming technique and event-driven architecture. This adoption is the result of both a lower barrier for entry in implementing asynchronous patterns and the built-in benefit for increased system resilience. Yes, when you have asynchronous patterns, you can also degrade gracefully. There's a bit easier. Now, the problem with this, as we were talking in the beginning, when we have event-driven architecture and asynchronous system, they are still difficult to reason about and understand. And because of this, we need observability. So observability is becoming increasingly important as a design time need. Can we understand all the interaction occurring within the complex system? So apparently this is what is going on. We are trying to, and architects or innovators, right, are trying to implement observability and build it into the infrastructure. Now, I'd be interesting in learning more about this, so I'll take a look on details for this, but it's quite good. Another focus area for architects is designing for portability, whether that's for multi-cloud or hybrid cloud. So the idea here is that you don't want to necessarily to get yourself bound to one provider. You want to have the option of either switching to another provider or of distributing your system between multiple cloud providers. Some of these clouds may be private and internal in the company because you can build some of these now, and some of them may be from well-known providers like Microsoft, Google, and Amazon. And here it's a bit, I know that this is a desirable thing, but it's still not that easy to do. So you see, when making decisions regarding standardizations, architects need to pick their battles. Right, there's a problem with corporate acquisitions because once you acquire a company, it comes with another set of cloud providers, and you might have separate hosting environments. So this will be important. It's easier to have only one provider for architecture, but it's also a risk on the long term. So it's a bit, we're still dealing with this thing. We don't have a solution. There are a few tools that you can use nowadays to kind of abstract away the cloud provider, but I don't think they are there. Holly Cummins has spoken on the subject of designing for sustainability, which is one of new innovator trends. This is emerging because people are realizing the software industry is responsible for a level of carbon usage comparable to the aviation industry. Absolutely. I was wondering when this will come and hit us, because obviously we are running. One thing that you can see is that CPUs and memory and hard drives, they have increased in capacity and in speed and all the necessary characteristics, and still we write programs that fill these available capacities, which is incredible. So I'm wondering if this will also lead to optimizations in our runtimes. Because part of it will be optimization in code, but I think I would expect that the first optimizations will be on operating system and on the runtimes that we use. So perhaps it might be interesting to look at improving, I don't know, the JVM so that it uses less carbon or things like that. I'm also wondering whether this will lead to the need to write some more bare metal type of code in programming languages like C++ or Rust. I know that writing microservices in C++ might sound like a very weird thing today, but C++ has come a long way from where it was 5-10 years ago. It's now become easier to write and easier to avoid problems that were plaguing C++ applications, like problems related to things like memory, well, security and memory allocation and things like that. You can pretty much avoid those with the current patterns that are available in C++. So let's see what they want to say. Some of this is almost directly measurable, as the bill for compute usage is highly correlated to energy consumption. Yeah, so there's a need for some optimization. Where CTOs and architects can have an impact is by either reducing unnecessary compute usage or utilizing more sustainable cloud hosting options. Some cloud data centers run on 100% green energy, while data centers in Virginia are powered by coal. Okay, this type of information will probably start to come up more and more on the providers list, right? If latency is less of a concern, then it may make sense to host in Iceland instead of Virginia. While many companies look to reduce their hosting costs purely for economic reasons, some are choosing to make sustainability a priority and architecting and deploying their systems accordingly. Now, I almost expect that there will be some regulation regarding the carbon foot, or how is it called, carbon print consumption for software applications at some point in time. I'm not sure it will happen, but it probably will at some point. Okay, another trend, correctly built distributed systems. Yeah, this is what we discussed. It's you need to find the right way to build these systems. And interesting, some of the trends around building distributed systems or modular monolith all come back to fundamental architectural principles such as high cohesion and low coupling. Yes, you need to know those and apply them all the time. Domain-driven design, while considered a lane majority trend, continues to be emphasized by architects looking for good guidance on context mapping and identifying boundaries within a system. Domain-driven design is extremely useful for finding out the structure of your distributed system. It's almost mandatory to use. You can probably use other ways, like looking at behavior rather than at data, but this is a very powerful way of doing it, and I think it's very important to use it appropriately. Similarly, the C4 model can be very useful to create a hierarchical set of architecture diagrams to help understand your system. C4 is a very good modeling or way of modeling your system, and this is why we use it in our courses on software architecture. It's quite easy to start with, and it maps on the thinking of developers and architects. So yeah, I know I think there are a few things that are missing from C4, but you can always add those. The structure itself and the ideas are very sound and very, very useful. Data architecture. So here we see data mesh, which remains an innovator trend this year. It is joined by data gateways, which are somewhat like API gateways but focus on data. As microservices have led to a polyglot persistence layers, API gateways offer abstraction, security, scaling, federation, and contract-driven development features. Contract-driven, very important, need to test your contracts. The role of the architect, this was the architect elevator, okay. Architects also need to be able to communicate with many audiences, described by Gregor Hope, I hope this is how his name is pronounced, as riding the architect elevator, talking to the CTO and other executives, that traveling down to the engine room to work with the developers. I would add to this that not only CTO, you might also get in touch with business people, you might also get in touch with IT, ops, with security, with testing, with all kinds of roles. So you need to be able to talk with all these types of people. So I don't see it quite as an elevator, I see it more like you have a range, a circle of people you need to talk to, and each of them require different language. Okay, so yeah, due to the pandemic, there are problems in communications. You don't have, since people are working remotely, you have a lot of written communication, like the architecture decision records, very, very useful. And, but you don't have that kind of osmosis, hearing from people. Yeah. Okay, and the last things, apparently there are two. So Dapper is one that we looked at. Open application model, which was introduced by Microsoft in late 2019, is a specification for defining cloud-native application and focuses on the application rather than the container or orchestrator. Cool. So there, I haven't seen this. We can quickly take a look. It's focused on the application. Okay. App-centric approach. Right, so this will need some more reading. And I think it's quite interesting that this is happening, because for too long we've been talking about, Docker, Kubernetes. Those should be infrastructure. We shouldn't care that much about them. It's great that they exist. As long as they function correctly, then we shouldn't worry about that. Okay. Both of these are open source projects, work on any cloud provider, and may join, I guess, some kind of code foundation. Cool. WebAssembly is another innovator trend. I'd be curious to see this, because until now WebAssembly has been quite limited. I would love to be able to write client-side code in other language than JavaScript, in Python or in another type of language. Particularly because we can bring some of the libraries that exist there, and I think that would be good for the web ecosystem. But let's see. I mean, I'm not sure. This has been in the works for a very long time, and until now I've seen only very, very few advances. For architects, it will be interesting to see if it is used as just a supplement to web frameworks and mobile developments, or if systems will be designed with WebAssembly in mind and how that will manifest. Now, with WebAssembly, one thing that you could do is write optimized code on the client side that runs within the browser, and the browser is almost like an operating system for it. And WebAssembly is fundamentally the assembly language for it. And this will allow perhaps some types of applications, like nicer games inside browser, and perhaps some data-oriented applications like analyzing data or things like that on the client. So it's interesting. Final note about GraphQL. there has been innovation, particularly at Netflix, for the next generation of GraphQL functionality, notable GraphQL Federation and GraphQL microservices. Okay, let's quickly look at those. GraphQL Federation. So this is, it basically has a subgraph inside the graph, and you can specify it a bit different. All right, so this is interesting. And then there's another InfoQ article on GraphQL microservices, which I would have to look at a bit more. All right, so this has been it. This is a very interesting article. You have the link in the description if you want to look at it. I think it shows a few trends that I've seen, not very surprising, but one thing that it shows, again and again and again, in software development is better to focus on learning the fundamental principles and applying them. If you know and understand very well high cohesion, low coupling, and the extension of the idea of coupling, which is connaissance, then you will have a lot of success, no matter the technology you are using, no matter the level of design where you are applying this, whether it's a method, class, package, API, or architecture level. These are principles that are universal, have been around for a very long time, and will not go away very soon. So I would make sure that I understand them really, really well, and that I can apply them at different levels. That's fundamentally what I find. The rest is not surprising. It's okay, there are a bit of new technologies that we can use that make our life easier, but in the end, it's just those technologies that actually map with these principles that really, really can help us. So I hope you enjoyed this. Let me know if I should read any and react to any other articles like that. And leave us a like, a comment, share, tell other people about this if they found it interesting. If you want to learn more about software architecture, we have a bunch of learning programs on this. Depending on your level of knowledge, we have something for you. And even if you are just curious about software architecture, we have the learning program from developer to architect, which you can join and satisfy your curiosity, learn how you can learn how architecture works. Right, thank you so much for listening, and until next time, remember to think, design, and work smart.